hopefully the two videos that I link to on the course page and that I can link to in the video description uh, indicate the kind of unprecedented changes that we're living through today. And I thought I would take this section to just kind of highlight several of the most dramatic anomalies, the historical trends for those of you who might not have seen those videos before or understand, I guess, at a kind of visceral level, the extent to which the international system is changing. I think for me, it has taken a number of years of really experiencing and seeing these things firsthand, reading about them. But I think nothing really compares to actually visually experiencing them to kind of understand the the size and the scale of the changes we're living through today. This is a graph that kind of shows the temperature anomalies from the world map, looking at historical trends. Globally, you look at the change in the average temperature from the 1951 to 1980 average. You see that just since 1980, the temperature changes have averaged over a half a degree higher than it was before 1980. So you can look. I'm trying to approach this in a couple different ways, right? To see some things will connect with certain people and not others, and that in order to really understand these changes and what the effect they might have on things that we care about, how long people live, how happy of a life they're able to live, where they're able to live, and what effects it might have on the political stability of their country. The magnitude of these changes, I think, are important to understand. So the world is getting hotter. Probably won't come as that much of a surprise. Australia's increase hasn't been quite as dramatic, but it is quite large also since 1980, both for sea surface temperatures as well as air temperatures. And there's a lot of different ways of trying to bring it home, depending on what context you're living with and where you are. These kind of effects might shift or be slightly different, but the overall trend is in the same kind of direction. CSIRO has released a couple of reports. This one is a good introduction. It came out a couple of years ago, looking at how the existing trends for the last 50 years are projected to go forward in the future. For the students who are writing literature reviews on different topics, it can often be tempting to try to focus on what's likely to happen in the future. And we do talk about prediction in this class, but the focus is on description and explanation, describing what's actually happened and why it did, and then that will enable us to make a theoretically informed prediction about what's likely to happen in the future. These reports do something similar, but I really want to focus on understanding the why, and given the nature of these changes, why there hasn't been dramatic action to try to prevent it. Tying it home to us in Canberra, the page from the CSIRO report that's relevant to us suggests that there's a high confidence that there's going to be a harsher fire weather climate in the future. Yeah, the last year has taught us anything, 2003 and before, fire is probably the most intense change, as well as drought, the changes that we're going to likely face here in Canberra. And the bottom, you look at the number of predicted number of days over 35 degrees or 40 degrees Celsius. The average number of days over 35 is estimated to go from a little over 7 now to 12 in 10 years. And the number of days over 40 degrees Celsius is going to go from 0.3 now up to 4.8 in 2090. Remember what I said at the beginning. A lot of the estimates at different time spans that I've just lived with since the 1990s have ended up underestimating the effects, in part because of the difficulty in predicting interactive effects, feedback loops, and the things that we've talked about in this class, that a lot of the models have difficulty in understanding tipping points, changes in equilibria, how the system, which is enormously complex, can change more dramatically than we expect. And I think for me, this is another one of those things that took a long time, understanding the shift in the number of warm days. I come from Los Angeles. We had warm days when I was growing up, but the number of days the U.S., California is living through a really horrible heat wave now. Last Friday, there were rolling blackouts in California, again, because of the load put on the electrical grid because of the heat. This is a histogram of temperatures as close as I could find to Canberra. The Bureau of Meteorology is great. You can geek out with the data as much as you want. I downloaded the data from Burrinjuck Dam because their data went back to the 1965. The Canberra airport data only started in 2008, and so I wanted to get as much data about what the average temperatures look like. This is the daily maximum temperatures, and so you see relatively few days below 10 degrees as a high, or over 40 degrees. And they're relatively rare. But with the change in the climate, if you shift, and so you can see this is roughly a normal distribution. If you shift the normal distribution just a little bit to the right as the temperature gets warmer, the number of days above 40 degrees or 35 degrees are going to climb quite dramatically. That steep slope on either side of the normal distribution suggests that even a little bit of a nudge higher will dramatically increase the number of high days. And I've driven around and lived here long enough to know how many people have evaporative cooling or not sufficient air conditioning capacity in their homes, that you could have a real risk of for people with older people or children having to deal with issues related to heat. My daughter, who's now 2.5, about 8 weeks after she was born in January, I guess that would be 2018, there was like a 9 or 10 day period in which the temperatures were like 38 degrees or higher. And our air conditioner in our rental unit couldn't handle it in our townhouse. And the temperature was so high we didn't feel safe keeping our 8-week-old daughter there, so we ended up having to stay in a hotel for 2 weeks because the air conditioning was crucial. Maybe we're American, we're spoiled with air conditioning, but you see with heat waves in Europe, you have a lot of people who are older that ended up dying because of heat waves. So these data are from Burrinjuck Dam, and you can see just here the histogram, the number of days over 40 degrees Celsius. There was only 4 days above 40 degrees C from 1965 to 2000. So for 35 years, there was only 4 days above 40 degrees Celsius, right? Which might explain the building stock here. But just since 2000, there's been 46 days above 40 degrees Celsius. So you have 4 days in 35 years, and you have 46 days in 20 years. Even here, there's been a dramatic increase in temperature. If you're ever curious, I wasn't able to drive out. It'd be cool to shoot a video out on the dam where I'm actually downloading the data. But it is about an hour and a half drive here from Canberra. And unfortunately, my schedule won't allow it. So these climate anomalies are hitting home here in Canberra. The temperature is one example. The fires that we all lived with at the beginning of this year that seemed to have been about 10 years. This is a shot I took just about to drive over Commonwealth Bridge in January of this year. The fires were so thick. This is when I was trying to find an air filter for our house because the smoke was just intolerable, but nobody had filters. Costco had signs out in front, Harvey Norman, Bingley, JB Hi-Fi, everywhere that I could try to think of that would have a filter. They were all completely sold out. So yeah, you should be able to see Parliament here, but it wasn't visible. Just absolutely viscerally in place. Another one that kind of has meaning to me, to make it kind of real to me, Canberra is one. But when I was in college, I dropped out of college for a year to try to get, I don't know, I'd read too much Kerouac or something. I was a literature major. I probably told you that already. And ended up working on a small boat that took people in kayaks into really remote parts of Southeast Alaska. And we spent a lot of time in Glacier Bay. I took a week off and went backpacking up around the glaciers in Glacier Bay back in the 90s. And this is Paradise Glacier here, the satellite photo from back in 1984. I wasn't there that far ago, but you still could see marks of where the glaciers that had been there that had recently retreated. But even in the last 20 years, there's been quite dramatic glaciers withdrawal. You probably have seen glaciers collapsing in Antarctica or the Arctic. We're going to talk about later on in the semester. But for me, just seeing the Glacier Bay from 1984 and then here in 2009, basically the glaciers we're looking at right in the center of the screen from 84, the brown and white there, turn into that light blue of water. That's over a 5 kilometer withdrawal of these glacier systems in Glacier Bay National Park. Beautiful area. I would encourage you to try to go there. But it just shows the rise in temperature having these kind of effects in a whole bunch of different places that you could look at around the world. These are just ones that occurred to me because of my experience in these areas. So yeah, the world's getting hotter, and we're going to touch on how this has an effect on human security in later weeks. Right now, I'm just trying to describe the size and scale of the change. Last year, or is this 2013, Australia had to add a new color to our temperature maps because the temperatures reached something like 50 degrees Celsius in interior parts of Australia. You were getting to the place in which certain parts of the world might no longer be inhabitable in different parts of the world. This, the picture on the left is of a video. I can share the link where a palm tree in Kuwait just randomly caught fire because of the temperatures were too high. A couple of these press reports are from the last couple of years. I could update it with any basic. Oh, that was from the video. I don't want YouTube to copyright flag that one, so I don't want to play it. But basically, these kind of heat waves are becoming more frequent and more common. Two places hit 129 degrees a couple of years ago. These are also becoming more common. Iraq, you see a lot of press reports about this, but Iran, the heat dome made an equivalent of well over 50 degrees Celsius in Iran. And you see more and more reports that, again, with that kind of normal distribution, if you get the extremes to be farther and farther out, it just might not be possible to inhabit in certain parts of the world. You see reports, predictions that there are going to be places too hot for human survival, and that's going to lead to refugees and conflict. We're going to, in the readings for this week, you see people discuss Ban Ki-moon, the UN Secretary General, and others 10 or 15 years ago made confident predictions that these kind of changes are going to lead to increases in conflict in certain areas. You see Adine Salayan and others kind of push back on that, saying that conclusions aren't there yet. But there are changes and pressures that's going to make it harder for people to live and work in places, which are going to tie into our weeks on population and migration coming forward. And you can see more and more reports talking about this climate migration. How are states responding to this? One of the lessons from the last couple weeks is that states that have resources have a buffer in their ability to respond and deal with these difficulties. We're going to focus more in week 11 on domestic responses and in week 12 on international responses, but it overlaps, and for your literature reviews, the topics overlap, and you can start to think about how states play a role, because often politics is missing when you just start talking about the science, like I have, about how these things are changing, and less on how governments are responding. This photo, I don't know how many of you might recognize it. It is from a breached levee in New Orleans in 2005 after the Katrina hurricane, man made disaster due to the inadequate building standards for the levees around New Orleans. But New Orleans is a city I spent 4 years living in, teaching at the University of New Orleans. Started in 2009, 4 years after the hurricane. The damage was still there. It's still there today, but it was recently after the U.S. National Guard, which had been providing police and security services in the area since Katrina, had recently withdrawn, and the city was still recovering, and it's now being hard hit by the COVID-19 crisis. But this is an area in which you see, even in a developed country, the susceptibility to the implications of these climate changes are ones that are quite dramatic. Here's a picture of a couple of National Guard in the area. This is in the bayous outside of New Orleans, near the coast. We used to go for runs out in Barataria Preserve outside of New Orleans. That picture was from Isle de Jean Charles on the Gulf of Mexico. This is an area in Louisiana that's the hardest hit because of climate change and rising sea levels. You might have heard about the effects of rising sea levels on Venice, but Louisiana is probably the hardest hit area for rising sea levels in the United States. Florida is also susceptible to it. But the estimates that I've read, loses basically a football field's worth of ground, to the rising sea levels per year, and it's going quite dramatically. So there's an interesting report on the New York Times I want to encourage you to read, looking at these people who come from Isle of Jean Charles. You can see the picture in the area in which these low-lying flat areas, even a small level sea rise is forcing people to be displaced, and the government has had to spend some money to try to relocate people who weren't able to basically survive given the rising sea levels. I know students every year in Australia want to write papers about sea level rise in the Pacific, but this is something that's also happening in other areas, though Louisiana in the United States undoubtedly has more resources to try to help with the relocation than small island states in the Pacific. The United States is currently in a hurricane season right now. Luckily, there hasn't been that many big ones so far, though we haven't really gotten into the worst part of the hurricane season. Hopefully, it's supposed to be a worse than average hurricane season, but luckily it hasn't happened that much yet. This is a photo of the U.S. New York subway system in 2012, in which there was widespread flooding due to Hurricane Sandy in New York City, and one of the oldest subway systems in the world, that is, of course, underground, and with rising sea levels, it's susceptible to this kind of flooding. There's been efforts to try to prevent it, and lessons that they've tried to learn from other areas who have to deal with these kind of challenges. The Netherlands being the most obvious low-lying area that has one of the world's leading systems of trying to hold back rising sea levels. And this is an area that's well outside politics in the engineering aspects, but in the funding aspects of these kind of systems, politics is really crucial to try to understand how and why these things are implemented and to what extent. In New Orleans, after Hurricane Katrina, the U.S. Corps of Engineers, which is responsible for building these kind of levees, built back a lot of them stronger. But there's decisions about how much, like, do you want to raise levees up to cover a 1 in 100 year storm or 1 in 500 year storm. Each increase in level costs additional money, and where do you try to strike that balance, safety versus actually spending money? The U.S. has an interesting system in which if your home is uninsurable on the private market because it's in a risky area, the United States will step in and provide that home insurance for people. And that's a political decision to protect certain vulnerable populations. But as more and more people making claims for that, there's been more discussions in the United States, at least, for how to reach a decision about what places you might want to encourage people to resettle from. After Katrina, there were some discussions in the U.S. about whether New Orleans should be rebuilt at all, and whether people should just stay in Houston or wherever they moved. But the understanding the pull and importance of the place, it's not surprising that they did decide to rebuild. Linking it back to Australia briefly before I take a break, there are, like I've talked about the United States, but there's been similar reports in Australia about the other areas that are vulnerable to climate change and sea level rises. This report from the Department of Climate Change says as of 2009, there are over 711,000 addresses within 3 kilometers and under 6 meters elevation of the coast. Not coast. You can look at a couple of different areas. You see different states in this graph show the number of residential buildings at risk of flooding with a 1.1 meter sea level rise and a storm surge. New South Wales and Queensland at the highest risk. I've been here long enough to see the flooding in Brisbane to realize the risk of that. Victoria, South Australia. I don't think in ACT we have to worry about the coast too much. And you can look at within in the New South Wales, different places within it are at varying different risks. I was going to try to find a good picture of houses on the North Shore collapsing into the sea. People love living next to the sea. I come from Los Angeles, Malibu, Pacific Palisades. You'll see a house randomly fall into the sea because of beach erosion. A way to visualize it here, looking at the different Sydney councils, you see certain areas are more susceptible to flooding than others. You can see Royal down there in the south. And in Cairns, you can also see a number of places in red on the right side in which if you do have a storm tide of over a million, of over a meter, the number of houses that would be at risk of this. And I think just I'll kind of end it there, but the takeaway is that there are increasing climate anomalies of temperature rises, sea level rises, ice melting in different parts of the globe we're going to be covering later on in the semester, and states' buffering capacity to be able to address that is going to be an ongoing issue for this class, because politics is playing a role in trying to address these challenges, and the inclination and the funds and the challenges can be localized within a country, right? Sydney is not the same as Canberra. Tasmania is not the same as Western Australia in the kind of challenges they face. And so in that kind of level of analysis question we've covered in this class so far, you're looking at the national level in the United States or in Australia or elsewhere misses out on a lot of that regional variation that we're going to be touching more on in this class.